Integrated Math 3, this is part 2 of the answers video to problem set 5.01. And it's called SOH CAH TOA, and on the first video I didn't explain what that means, so let's just go ahead and understand. It's a mnemonic. A mnemonic is a way you remember something, so you can write this down. So the SOH, S-O-H, is sine equals opposite over hypotenuse, SOH. The CAH is cosine equals adjacent over hypotenuse, C-A-H. And TOA is tangent is opposite over adjacent. So it's just a mnemonic to remember those relationships. Okay? All right. Now, problem 5, we get into a slightly different question. In the previous problems, we were given a side and an angle and asked to figure out the other two sides, or at least one of them. In this case, we're given two sides and we're asked to figure out what the angle is. And that's going to require an inverse process. Remember what an inverse is. It's a math function that reverses another math function. So subtraction is the inverse of addition. If I take the number 5 and add 3 to it, and then I subtract 3 from that, you go back to 5 again. If I take 5 and multiply it by 3, you get 15. If you then divide 15 by 3, you get back to 5 again. So the two reverse each other. Addition, subtraction reverse each other. Multiplication, division, square, square root, those are all inverses. Okay, we talked about exponentials and logs in the last unit being inverses. So here you have an inverse of, you're going to use an inverse of sine, cosine, and tangent here. And I'll show you how to do that on the calculator. All right, so again, the first thing we do, and what I want you to do is I want you to figure out all three sides and all three angles. It's really not that much extra work to do that, rather than just this. But I want you to figure out this side as well and this side. So first of all, we label the side. So the longest side is the hypotenuse. Okay. Then here's the angle. So the side opposite that is the opposite. And then the other guy is the adjacent, the one next to the angle that we're interested in, but that is not the hypotenuse. That's the adjacent, okay? All right, so what do we have here? What do we know? We know the adjacent and we know the hypotenuse. So that means that we know the cosine relationship here, that it's going to be adjacent over hypotenuse 11 over 15.2. So we're going to go ahead and write this cosine of theta, because that's our unknown, equals adjacent over hypotenuse, this. So that's going to be 11 over 15.2. Okay, so now we have theta, which we're trying to find wrapped inside of a cosine function here. So the way we get it out is by using an inverse cosine function. And there's two ways to write the inverse. It could either be written arc cosine of theta, or it can be written as cosine raised to the -1. It's not an exponent. It's not really raised to the -1. It's just the way they indicate the inverse of cosine of theta. So these two mean the same thing. They're an inverse of this function. So if we want to get the theta outside of this cosine here, we have to inverse it so that it comes out. Okay, so this time we'll use the arc cosine. I usually use this one. And the calculator we're going to use, the online calculator, uses this one as well. But let's go ahead and use arc just this first time. Okay, so it's going to be arc cosine of theta equals arc cosine of this, 11 divided by 15.2. Just remember, anything you do to one side of a math equation, you do to the other side. Okay? So arc cosine of theta is simply going to be theta Okay, and arc cosine of this is going to be, well, so we're going to go figure it out. All right, so we're going to go to our online calculator now. Okay, so again, we go to Google. If you don't remember how to do this, go to online calculator. There it is right there. Click on that. It brings this up, but I still recommend I don't use this one. It looks like it has everything we need, but I don't use it because it might not appear on your when you do this search. I don't know whether it always appears. So there we go to online calculator. We get a calculator that's too simple for our purposes, so we go down to the bottom top center, go to scientific calculator, and this is the calculator we want to use. Okay, so what we want to know from the previous page is the arc cosine of 11 divided by 15.2. Well, I could do that all in one calculation, but let's just go ahead and figure out what that is. 11 divided by, and click the divided by sign, or you can just use the slash on your computer keyboard, and it's 15.2. And what we get is 0.7236, all that. Okay, now, how do we get the arc cosine? Here we've used the sine, cosine, and tangent. Well, you go down to where it says first in the bottom left, and you click on that, and it makes it secondary functions. And you see the keys turn dark green. Some of the keys do. And these are the inverses. So I told you they were going to use the -1 notation for these inverses. And so you're going to use cosine -1. You already have the number up there. With this calculator, you put the number in first, and then you hit the function. With the classroom type calculators we have at Hoover, the TI-30s, you do it the other way around. You hit the function and then the number. So I'll show you that as well. So it's cosine -1. I have the number up there already, and what we get is 43.64. I'll just call it 43.6. So that is the angle that we're dealing with here. Okay, so I'm going to go back 43.6. Go back here. And that's simply going to be, that equals 43.6 degrees. Okay, so that's the answer for theta. Okay, let me show you on the TI calculator in case some of you have one that have that calculator or have one like it. In that case, what you do is, here we have cosine, if we want to use a cosine function. If you want to use the second function, you see right above it, it's cosine -1 in the light blue there. So you have to do the function first. Second, cosine, and there's cosine -1. Okay, and the number was, I forgot what the number was. It was 0.72, I think, something like that. You put that in, close the parenthesis, and hit it, and it's 43 point, well, anyway, it wasn't exactly 0.72, but that's how you do it. Hit the function first, second, and then cosine, and then put the number in, close the parenthesis, and then hit equal or enter, and it'll bring up that. And so that's the answer that we get for that. Okay, let's go ahead and figure out the angles. So we know this one's 90. Always have to have at least one 90-degree angle in trigonometry, at least this far in trigonometry. Later on, we'll find out how to deal with it if you don't have a 90-degree angle. So remember what all three of these angles added up have got to be 180. So we're going to call it 180. Okay, that's angle A. That's the symbol for angle. It's actually angle B in this case. We found angle A. That was the 43.6. Okay, so it's angle B. Okay, so 180 minus this will give us this right here. So we'll go ahead. I'll just do that on my handheld calculator. 180 minus 90 minus 43.6 equals, and that gives us 46.4. Okay, now we have one more side to find out this one. We could use the Pythagorean Theorem. Here's the hypotenuse, c squared minus, if we call this side A, it doesn't matter which side is A or B. C squared minus A squared equals B squared. We could do that, but I'm going to use trigonometry. So you can either find the relationship between the opposite and the adjacent, or between the opposite and the hypotenuse. You want to find the unknown, what you're trying to find, and one of the known sides. So one unknown side, one known side. This is what we're trying to find. We'll go ahead and do opposite hypotenuse here. Okay, it doesn't matter. Both of these would give you the same answer. Opposite over adjacent would be the tangent, and opposite over hypotenuse, if we come up here, that's going to be the relationship between those two is called the sine. Okay, so, and this is the angle that we're dealing with here. Now, we could have dealt with this angle now that we know it, and we could have done, in that case, this would no longer be the opposite. It would be the adjacent, and this side would be the opposite, okay? So you got to be careful once you've written this angle, and that you're going to use this angle. This is the opposite of this angle. It's the adjacent of this angle. So there's all kinds of possible combinations, but let's just keep it simple. That's the angle we originally figured out. So it's going to be the opposite over the hypotenuse of this angle is going to be the sine. So sine of 43.6. All this might seem a little jumbled and confusing. It'll make sense after you work enough of these. That's why I want you to work all three sides and all three angles, just to get used to what those relationships are. Okay, so that's going to equal opposite over hypotenuse, which is opposite over 15.2. And now we come down here, and I'll go ahead and multiply both sides by 15.2 first. You could do that or figure out the sine of 43.6 first. It doesn't matter. I'll go ahead and close that in parentheses. So these two cancel out. So the opposite's going to equal 15.2 times the sine of 43.6. Okay? So let's go back to the online calculator here. Okay, I'm going to clear it. And I'm going to say 43.6. And then I'm going to go back to the first. Okay, I'm now on the inverse functions here, so I hit the second down here in the lower left, go back to first, because I want to know the sine, not the arc sine or the inverse sine. So there's sine right there. So there we get 0.6896, all that. Okay, now we're going to multiply that times 15.2. Okay, and it gives us 10.48. Okay, so this equals, the opposite equals, and I'm just going to, I did that calculation, I'm just going to put it over there like that, equals 10.48. I think that's what it was. Okay, and again, that's a distance, that's the length of this. Okay, so we figured out all three sides and all three angles. Okay, all right, let's move on. Again, you try to do this next one. Try to do all of them by yourself. Okay, you now know how to do these from those previous examples. Try to do them on your own. Okay, so again, we have an angle here, and we have two sides. So again, we have to identify what the sides are. Don't get confused when they flip the triangle in different directions like this. The longest side is hypotenuse. Okay, the side opposite the angle we're interested in, this side is the opposite. And the other guy is the adjacent, and that's what we're trying to find here is the adjacent. Okay. Well, actually, what we're going to find out first, we have to have the angle. We have to have the angle before we do it. We could find the adjacent, again, with Pythagorean Theorem. 15 squared minus 8 squared equals adjacent squared. And let's do the math on that. You'd have the adjacent. But we're going to figure the angle first. All right. So the angle is the relationship between opposite and hypotenuse. That is the sine. Okay, so... Okay, there we go. Okay, sine. All right, so now what we have to do is we have to take the inverse of both of these sides to figure out what theta is. We need to get theta outside of the sine. So we're going to take the inverse sine. This time we're going to use this notation of both sides. So in this case, it's sine theta. Okay, so the inverse and the sine, inverse sine and sine unwrap each other. They cancel each other out. You can basically do that if you want. So all you have down here is theta. Okay, and now we go to the online calculator to find that. So it's inverse sine of 8 over 15. So first we do on this calculator the 8 divided by the 15. We get this. And now we go down to the first function, click it onto the second, and go up here. Be careful, this SINH, COSH, and TANH are functions that we don't use in this class, okay? That comes in a later kind of math, okay? So it stands for hyperbolic, sine hyperbolic, cosine hyperbolic, but don't worry, you don't need to know it. Okay, so now we're at inverse sine, and there we go. We clicked on it, and it's 32.2. So I'll come back here, and that equals 32.2, and that is an angle, so it's degrees. So this is 32.2. Okay, let's figure out what this angle over here is. So again, it's going to be 180 minus the 90 degrees right here, minus 32.2. And that's going to be 57.8 degrees. Okay, so that's this angle right here. Okay, last we want to find out what this side is. So 3 ways you can do it. Pythagorean Theorem, we already mentioned that. You could have done that at the very beginning. The other way is the relation between the adjacent and the hypotenuse, that's the cosine, or the relationship between the adjacent and the opposite, that's the tangent. Let's go ahead and use this one. It doesn't matter which of those 3 we use, they'll all give us the same answer for this length. So let's use this one. Okay, so it's going to be, this is adjacent and opposite with reference to this angle, not this one. Okay, so be careful. The original angle. This is the adjacent to this angle. This is the opposite to this angle. So we're using this angle. We could use this one. We're not going to. So it's the adjacent to this, and this is the opposite to this. Okay. So we're going to say tangent. Adjacent. Excuse me. Opposite over adjacent. Don't get them confused. I just did. Opposite over adjacent is the tangent. And we know the opposite is 8. And the adjacent is what we're trying to find. So there you go. So now we got a 2-step algebra problem here. I'm going to scratch this out. It's in the way. We got to multiply both sides by the adjacent. And these cancel. And now you got to divide both sides by tangent 32.2. So let me rewrite what I have down here. Okay, so I just rewrote that down here. Now we have to divide by this. We need to get adjacent by itself. And since it's a multiplication between these two, you offset that by a division. You can just wrap this all in parentheses and do what I'm doing here. Or you could have gone in and calculated it first and come up with a number if you wanted. So these two cancel. And what you're left with is, I'll come and write it over here. You're left with adjacent. Let me actually write it up here. Equals 8 divided by tangent. Okay, there you go. Okay, so what I'm going to do now is go to the online calculator and do this calculation. It's kind of a little bit complicated because you got tangent down there at the bottom. So I'm going to go over to the online calculator here, and I'm going to clear it. And I'm going to do tangent 32.2 and then write it down. You don't have to do that, but I'm going to do that. First of all, we have to get out of the second functions here. I'm going to put 32.2, and then I'm hitting tangent. And I've got 0.6297. That's 4 digits after the decimal, so that's good enough. So 6297, write that down. And I have 8 divided by 0.6297, and that gives us 12.7. Okay? So that is going to be our answer for the adjacent. And again, that's a distance. So it's this distance right here. The distance of this side right here. Okay, so we have all 3 sides, all 3 angles, and that takes care of that problem. Okay, now we're on to problem number 7, and what you're trying to find is the cotangent of theta if the secant of theta is 5 over 4. So now we're getting into some of those additional relationships that we haven't used yet. So let's look at that. So they want us to find the cotangent. That's this one down here. And what they give us to start with is the secant. That's this one right here. So we know this, and we're trying to find this. So let's go ahead and write down what we know. We know the secant is the hypotenuse over the adjacent. Let's go ahead and write that over here. We don't know what the angle theta is though, but we know if the secant is hypotenuse over adjacent, then that's 5 over 4. And what that means is that the 5 is the hypotenuse and the 4, supposed to be an arrow, is the adjacent. Okay, so we know what the hypotenuse, we know what the adjacent is, and remember again, this has to be a right triangle. So I'm going to draw a right triangle here, and we're going to see how can we figure all this out. Before I do though, let me do one additional thing, is what we're trying to find. We're trying to find the cotangent. So the cotangent of theta equals, again, we come back to this sheet, and there it is right there. It's the adjacent over the opposite, okay? So this is what we have to find. All right, well, we know the adjacent already, it's 4. We don't know the opposite, okay? So what we have to do is we have to make this triangle and use the Pythagorean Theorem. It's the only way we can find out this additional side. We need to find out what the opposite is. We don't know the angle, so we can't use trigonometry. We have to use Pythagorean Theorem. So the hypotenuse is the longest side. Okay, and the adjacent, and we're going to say that this is the angle we're looking for right here. Okay, the adjacent is 4. That's the one that's right next to the angle. If you had used this angle, you could have done that, then this side would have been the adjacent. So let's just go ahead, but we're going to, so you get to pick which side you want to be the adjacent. So we know the hypotenuse. We know the adjacent. And what we're trying to find is the opposite over here. Okay? All right. So we need adjacent over opposite to give us the answer to this. So again, since we don't know the angle, we have to use the Pythagorean Theorem. So Pythagorean Theorem is a squared plus b squared equals c squared. And we're trying to find, again, you can label whichever side. This has got to be side C. The hypotenuse is always side C. Either one of these could be A or B. I'll call this one A and this one B. It doesn't matter which is which there. Okay, so what we're trying to find is A, the opposite. We're using the Pythagorean Theorem. So the way you do that is you subtract, that should be b squared, you subtract b squared from both sides. These cancel out, and you have a squared equals c squared minus b squared. Again, this is 7th or 8th grade math right here using the Pythagorean Theorem, or integrated math 1 at the very latest. You should have had this, right? Okay, so there it is. So now we're going to plug in our numbers. The hypotenuse has always got to be c, so that's 5 squared minus, there's b, 4 squared, and that's going to equal 25 minus 16, which equals 9. So that equals a squared. So if a squared equals 9, then a equals 3. And we've seen this triangle before. It's a 3, 4, 5 triangle. 3, 4, 5. Okay? It's a very common triangle. All right, so we now know the opposite. So now we can come up here. We know the adjacent. We always did know that from here. We don't need the hypotenuse to answer this question, but we know the adjacent. We knew that all along. And now we figured out the opposite. So this is going to equal the adjacent over the opposite, 4 over 3. Okay, and that's the answer to the question. They want to know what that cotangent is. There it is. You can leave it as a fraction. You don't have to convert it to a decimal number or anything else. So the cotangent of theta is going to be 4/3. So let's review that. They gave us the secant, 5/4. From this sheet right here, we see that the secant is hypotenuse over adjacent. So the 5 has to be the hypotenuse and the 4 has to be the adjacent. So now we can create a triangle. There's the hypotenuse is the 5. If this is our angle right here, then the adjacent is the 4. Now we use the Pythagorean Theorem to figure out that the opposite is 3. So it's a 3, 4, 5 triangle. If you just knew that, you didn't have to show the calculation if you just knew that. Okay, and some of you do. All right, so now what we're looking for is cotangent. We come up here. Cotangent is hypotenuse over adjacent. Excuse me, wrong. Cotangent is adjacent over opposite. Okay, so there's adjacent 4, there's opposite 3, so 4/3, and that's the final answer for the cotangent. Okay, let's go on with the next one. All right, so they want you to find secant of theta if sine of theta is square root of 2/2. All right, so we come over here. We're going to do the same thing. See if you, again, always stop and see if you can do this. At least give it, I would say, 30 seconds to a minute of thought how you do it. First thing you want to identify is what two sides, opposite, adjacent, or hypotenuse, is sine of theta. Which two sides? Okay. All right, so stop the video, try it, and now I'll go ahead and do it. Okay, so sine of theta, we come up here, sine is opposite over hypotenuse. Okay, so I'm going to come over here, sine equals opposite over hypotenuse, which means in terms of this particular question, it's the square root of 2 is the opposite, and 2 is the hypotenuse. Okay. All right, so now we're going to do the same thing. We don't know the angle, so we can't use trigonometry. You have to know the angle to use trigonometry. So we're going to come over here, do the same thing we did last time on number 7. Okay, so this is the angle we're going to use right here. So if this is theta, our unknown angle, then the hypotenuse is the longest side. And we know what that equals. That equals 2. And the opposite is the side way over across. And that equals the square root of 2. Okay, now again, we don't know an angle, so we have to use Pythagorean Theorem to figure out what the adjacent is. Well, first of all, do we need to know that? Let's go ahead and, what are they asking for? They're asking for secant of theta. And what does that equal? Secant is hypotenuse over adjacent. Okay, this side is the adjacent. Okay, so we know the hypotenuse right there, it's 2. We know that right there, 2. So we know this top number. What we got to figure out is this one. And again, we have to do exactly what we did before. So I'm going to call this side C, Pythagorean Theorem. This is going to be side A, and this is going to be side B. Okay, so we saw from up here that we need B squared this time. So anyway. So it's a squared. It doesn't change anything. Let me just go ahead and do the algebra for you. So c squared equals a squared plus b squared. Okay, and we're trying to get b by itself. We need to find out b, so we're going to subtract a squared from both sides. These two cancel out, and what you end up with is c squared minus a squared equals b squared. The b squared's all by itself on the right side there. Okay, so now let's plug in our numbers. C is 2, so 2 squared minus a is the square root of 2, so that's going to be the square root of 2 squared equals c squared. Excuse me, equals b squared. Okay, 2 squared is 4 minus the square root of 2 squared. Remember, that's an inverse. They inverse each other. So the square root of 2 squared is 2 equals b squared. So b squared equals 4 minus 2 is 2. So if you take the square root of b squared, that equals the square root of 2. And so that means that b equals the square root of 2. Square root of b squared is b. Square root of 2 is just the square root of 2. So that means this is going to equal, that's the adjacent, that's going to be the b side, that's the square root of 2. Okay, so now we know the hypotenuse is 2, the opposite is square root of 2, the adjacent is square root of 2. So now we can just come up here. Hypotenuse is 2. Adjacent is square root of 2. Now, you would say that, okay, that's our final answer. We have the hypotenuse over the adjacent. However, there's a principle of math that says you're not supposed to leave a root in the denominator. That's just the rules of math. You're not supposed to do that. So how do we get this out of the denominator so you don't have a root down there? And the answer is you multiply top and bottom by the square root of 2. Remember that any number over itself, square root of 2 over square root of 2, just equals 1. And this multiplied by 1 still equals this. So we haven't changed the value. So that's legal to do that. This basically equals 1, and you can multiply anything by 1 and still have that same number, still have this value here, okay? So what do we get up here? We get, on the top, we get 2 times the square root of 2. You can't simplify that really any further. And on the bottom, we have the square root of 2 times the square root of 2. Again, that's the square root of 2 squared. Square root of 2 times square root of 2 equals 2. Okay, so now we have that, and now you just have one more step to simplify it. I'll go ahead and write secant theta equals, and that is that these 2's can cancel. So all you have left is the square root of 2. So that, finally, is your final answer. Okay, that was a lot. There was a lot there, okay? So this problem started off like the one just above. Okay, you said, what is sine in terms of opposite and hypotenuse? Okay, and it is the opposite over the hypotenuse. So that means this had to be the opposite and this had to be the hypotenuse. So we drew a triangle, picked one of the angles other than the 90 degree to be theta. We picked this one. So the hypotenuse is the long side, that's the 2. Okay, that's this number here. And the opposite is the top number here, the square root of 2. So we have 2 there, square root of 2. We had to use the Pythagorean Theorem to figure out what the adjacent is. And when we did that, through all this calculation here, we came up with this being the square root of 2. So now we do know, now we have to know what we're trying to find out is secant, which is hypotenuse over adjacent. So we already knew the hypotenuse was 2. We now know the adjacent is square root of 2. So we just wrote that, 2 over square root of 2. And normally you'd say, okay, you're done with the problem. 2 over square root of 2 is hypotenuse over adjacent, you're done. But the rules of math say you can't leave a square root or any kind of root in the denominator, in the bottom. So the way to get rid of it is you multiply the bottom and the top by whatever this is. So square root of 2 times square root of 2 gave us 2. And 2 times square root of 2 gave us 2 times square root of 2. The 2 on the top, the 2 on the bottom canceled out. You're left with just the square root of 2. And that's your final answer for secant theta, okay? So if you're really serious about this, learning this, I would practice that problem a couple times until it just seems natural. Even if you just memorize it, just kind of learn those steps, okay? All right, let's keep going. Number 9. Okay, so here we're given an angle. Now we're going back, really, this is going back to the problems we did near the beginning. We're given an angle and a side, and we're asked to figure out the other 2 sides, and I'm also going to ask you to figure out this angle right here. Now you could do that right away. So let's do that. I tell you what, we'll wait on this because if we put this angle here, you might get it confused with this angle. You could get them backwards. So let's just deal with one angle here so we're not getting confused. So the first thing you always do in these problems is label the sides opposite, adjacent, hypotenuse. Longest side is hypotenuse. The side across from this angle is opposite. And then the other guy is the adjacent. This side over here is the adjacent, okay? So it doesn't matter which one we find first. Let's go ahead and find x first. So x is going to be the relationship between the opposite and the hypotenuse. And again, go back to your first page. And that relationship, opposite hypotenuse, is the sine. Okay, so it means that the sine of 45 degrees equals opposite 3 root 2 over the hypotenuse, x. Okay? All right. Now, again, you can go ahead and figure this out right away if you want, or do the algebra first. I'll go ahead and figure it out right away this time. So sine of 45, come up here. Okay, so it's 45 degrees. Again, you want to be sure your degree over, this is set to DEG. If it's set to RAD, it's wrong. You got to just click it and set it to DEG. So 45 degrees, and we want the sine of that. So that gives us 0.7071. So I'm going to go back. So this equals 0.7071 equals square root of 3. Excuse me, 3 square root of 2. Let's get that right. Over x. Okay, now it's 2 algebra steps. First one is you got to multiply both sides by x. Cancel, cancel. And now what you have is x times this. Okay. All right, now you got to divide both sides by this. This one. Okay, these two cancel out. So you have x equals. Now usually when you're doing trigonometry, you leave things like this form 3 times square root of 2, but you haven't learned that yet. It has to do with something called that we're going to learn in about two or three lessons from now. 2 lessons from now, I'd say. Okay, so we're going to go ahead and just do this calculation. So it's 3. First thing I would do is take the square root of 2, then get that number, multiply by 3, and then take that and divide by 0.707. So I'm going to do that on my hand calculator. No, I'll do it on because it could be a little complicated here. Okay, so I'm going to clear. So I'm going to put in a 2 and then square root, and you get 1.414. Now I'm going to multiply that by 3, and that equals 4.242. And then I'm going to divide that by 0.7071. 0.7071. And we hit equal, and we get 6, just about exactly 6, okay? So that means x equals 6. X equals 6, so that means this side is 6. All right. Now we got to figure out y. I'll do that over here. Let me move this because I'm going to need some space over here. Okay, so here now we can do either relationship we want between adjacent and hypotenuse, that would be the cosine, or between adjacent and opposite, that would be the tangent. Opposite adjacent is tangent relationship. Again, you go and you find those relationships over here. Okay, we're going to go ahead and use adjacent hypotenuse, that would be the cosine. So the adjacent of 45 degrees over the opposite. Over the hypotenuse is 6, is going to be the cosine of 45. So I'm using adjacent hypotenuse. So the cosine of 45 equals adjacent, that's what we're trying to find, over hypotenuse, which is 6. Okay. So now we can multiply both sides by 6. Cancel, cancel. And you have adjacent equals 6 times cosine of 45. So let's go to the calculator. Okay, so it's going to be, and it's 45, then you need the cosine, and then you're going to multiply that by 6. And we get 0.424. Okay, so that's going to be 4.24, rather. 4.24. Okay, so this side is 4.24. 0.24. Okay, whoops, hammer here. Now I'm going to tell you something. Your calculator doesn't work in numbers like this with roots. It works in decimals. But if you do the math on this, this is also 4.24. Okay, if you square this and then square this and add those two together, you'll get this squared. All right, so that's what a 45-degree angle is. So if this is 180 minus 45 minus 90, this one's also going to be 45. Okay, so 180 minus 90, that's this angle, minus this 45 that we know, equals this angle right here. Okay, that's the unknown angle. Okay, I didn't label it, but there it is. And that's going to equal 45 degrees also. So that's what you get there. All right. Okay, so there's 3 more problems to go on this, 10, 11, and 12. I'll do those on a third answers video. I don't want these videos to go too much beyond 30 to 40 minutes, okay? So I'll see you on the next video for the rest of the problems.